In session 10, we have learned node, node edit, temporary nodes and distance panel, line and line edit panels. In session 11, we will learn what is free run and how to perform free run. Now, what is free run? Free run is a subtype of normal modes analysis which is used to find the connectivity of a model or a geometry. Now, why do we need to find out whether the geometry or a model is connected or not? It is needed so that when we apply the loads or constraints, we should get the proper results or the desired results. If a model is not connected, we might not get the results, we might get errors instead. Now, why do we get disconnected model in the first place? Now, we get disconnected model because CAD software works on a different platform and a CAE software works on a different platform. When you import a CAD geometry in a CAE software, there are some data loss because of the two different platforms. Now, because of that data loss, some of the geometry might go missing. That's the reason why we need to perform free run before doing any analysis to make sure that the entire model or the geometry is connected. So, how do we perform free run? To perform a free run, we need to use normal modes analysis. We give the following inputs in the software. First, we define the frequency range and the number of mode shapes. Next, we do not constrain the model in free run. So, model is completely free. None of the degree of freedoms are constrained. Now, what is meant by frequency range and number of mode shapes, etc., etc.? This we will discuss in more detail in normal modes analysis session. Here I will just show you what mode shape actually looks like. So here is an example. For any physical domain, let's say any component, there are n number of mode shapes, which is infinite. So how many mode shapes do you want to see? That number you have to define to the software. For free run, that number is completely arbitrary. You can give any number you want. It is recommended to give a number of more than 6. Now, once you give a number of more than 6, so after I will show you these mode shapes. A mode shape is nothing but a vibration pattern, which you can see here. So this is nothing but a mode shape, which is nothing but a vibration pattern. Using this vibration pattern, we can tell whether the elements are connected to each other or not in a mesh. So to explain that, let us take an example here. In the figure, you can see a beam. Now there are lots of elements on the beam. You can see how the beam is divided into multiple sections. All these are elements. Now, which of the elements are actually connected and which of the elements are not connected, it is very hard to find out just by looking at the mesh. Like if you take a look at the picture right now, it is very hard to find out whether it is connected or not, or it is near impossible to tell. That is the reason why we perform free run. Now once we perform free run, we get results something like this. Here you can immediately notice what is happening. You can see that the top example has every element vibrating together. So it means everything is connected. In the second example, you can see how the elements are disconnected. Only one part is vibrating and another part is not vibrating. This is why we perform free run, so that we can see this kind of issues just by looking at the animation itself. This is also called as a mode shape. So I hope it is clear to everyone. This is all that we are going to cover in this session. Thanks a lot for attending session number 11. In session number 12, we are going to cover problem statement on free run. That is, we are going to see how to perform free run in HyperMesh.